Nice.
We get, yeah. Few more weeks to go.
Yeah. 4 weeks, man. It's only one month. So our like next term will start from November.
You're doing term 3? Yeah, maybe November. I'm not teaching term 3, so I don't know the dates.
So we need to like if we want to join the term 1, leaving term 2, is that possible or not?
Yeah, I think you must do 2 terms, right? But there is no requirement you must do 3 terms.
Okay.
So you can leave term 3 and do again in term 1, but it depends on your plan. I think course advisor have given you the plan.
No,
nothing else.
You should know what unit you're doing in different trimester. Yeah. Did you do term 3 before? No, this is the first time. Yeah.
They didn't email you.
I don't think that in civil engineering.
Timetables for
Yeah.
the course.
no.
Then they emailed that.
So yeah, listen carefully. Hey, you did this and Australian engineering practice, right?
Yeah.
There is no unit for you in term 3.
Yeah. For vacation.
Yeah, you can't do term 3 because civil, only 2 units we offer in term 3. Geotech, this unit, and Australian engineering practice.
Okay.
For civil. All others you must do either in term 1 or term 2.
Okay. Then term 3 will be
Holiday for you.
holidays. It's like
This one. That shows the course and what term.
Yeah, term 3 we offer only geotech. Okay, we don't offer any other unit in civil.
But it depends on you.
Your plan.
this was sent you when you were enrolling in the
Yeah.
center? Enroll?
Yeah,
They emailed me.
the course advisor give you the what unit you're doing in what term.
Because next year already we're going to select what
I'm
specialty.
sure you guys are in term 1, you are doing transport with me.
Yeah.
Yeah, that's what I think. And then
if you choose municipal, we'll be doing transport. If
you
choose-
must do transport. No, even structural they take transport because that's elective you can take anyway.
Oh. We can take both.
Yeah, we can take both because as an elective you can do transport as elective if you are doing structural stream.
Okay.
That's fine.
Yeah.
But almost all students they do transport. Maybe I'm too popular here. Yeah.
Yeah.
Okay. You'll realize later on. Okay. Not geotech. Right. In transport you will see me. All right. Okay. Transport would be the good. That's my real research area anyway. Of course, geotech also I do, but little of these things, right? Yeah. Transport is better for me. Okay. Anyway.
Ask for this on first floor.
First term.
For this.
First floor?
Yeah. You could ask for this on first floor.
Yeah, in the ground.
You asked for this?
I think level 1 first.
This one. They emailed me.
When you are like you got the
Before
COE?
I got my visa.
When you got your visa?
When I got my visa.
Or COE?
What?
When you got your COE or visa?
My visa.
Visa?
Visa.
No, in level 1, there are some people in level 1, You can go and ask, not us. Okay, we can't track which student is what level. So they are the one that are doing that. Okay, I'm sure you will be doing the transport in term 1, and there is a one structural unit. Okay, and the term 2, you will be doing water, and another one electric. Okay, and then you need to do internship, you need to do CPD, and then you graduate. That's it.
So
And the 2 projects. Oh, by the way, 2 projects there.
So we can do our internship like in Tom 1 or not?
Yeah, of course, term 1, term 2, any time is, but it depends on your plan. Okay, where you are supposed to get that, right? I think yours is last one. Is that make sense? Last term?
Yeah, last term.
Last term, all right. Usually they do last term. Okay, internship. It's better you do internship last.
Yeah.
The reason is there is a possibility of getting job over there after you finish your degree. Because I get a lot of emails from students right now. They say that after finish the internship, usually they are offered job there. But you need to go a little bit rural area, guys. Yeah, I shouldn't tell you this type of things, but you see, this is the career type thing. If you go a little bit regional area, they are desperately looking for people to work with them.
Yeah,
But if you stay in Melbourne, it's too competitive, right? So many people here.
Yeah, this Victoria regional area is also like.
Not like Queensland regional or Western Australia regional, okay? Their regional is really regional, you can't live there. But Victoria is very small. Anywhere you can go from here is 5-6 hour drive anyway. Yeah, you can reach any side of Victoria.
If we go in job back, we'll move now.
No, I am, because many students, I'll tell you my story, right? Many students, my previous students, we did transport, learned 2 softwares, right? Sidra and then the Sortly. Those software are so commonly used here. If you are good at these 2 softwares, right, hopefully it will not happen like this software, right? Access from online is all right, that everything is okay. You learn a lot. If you do these 2 softwares very nicely and you can have a good interview, usually you get job. But you need to go either Geelong, Ballarat, Bendigo to start off.
Regional.
Slightly regional. They are not regional. They are city guys. Hey, you have been. They're not Melbourne. Don't look at for like a Bangkok or Tokyo. Hey. Of course, Australia is very. Population is so low anyway. So yeah, you go a little bit, and then you convince them. You work very hard during your internship, and then they usually offer you job. I got like last week two emails from students. They were offered job already. Okay, so you need to be ready for yourself, right?
So we need to complete our study to get job?
The internship usually is complete already anyway.
No. If we try like now, we can get...
Now it's a little bit difficult.
Yeah.
Okay, so at least local software you need to use. GeoStudio is not local. Yeah, this is the international Canadian software. But what we will be learning in transport, they are the local Australian softwares, both of them. Okay, that is my aim is just to prepare for you ready for the job, something if you get some chance. Not all get jobs, okay? Yes. So you need to be little bit strategic, what project you do, yeah, project is there, and then what software you learn and master it, yeah, and then go in that area. Mine, they go in either Sidra or certainly transport sector, pavement design or traffic analysis.
Can we just do internships now?
You can, but it's too early. Don't go for that.
So to be eligible for the internship, like
I think you need to do 3 units or 4 units. You need to
we need to be like on 32 credit, you know.
I think 36. 36 is 3 unit equivalent anyway. All right. Okay. So just complete those and then go. Don't go internship now. It's too early. Okay. Any other questions? Career, life, whatever. All right. Okay. Let's start. I'm not going to cover all, right? We'll do a little bit few, just quickly. Of course, I'll continue on Wednesday. Okay? So now what we learned last week, did you watch my recording from previous year about swell reinforcement? Not yet, yeah? Please do that, right? Theory is there, but we solve the problems. Problems are only those types on Wednesday recording there. Watch them and practice few problems. Okay? So another thing is we are going to have a online exam. You can do from home. It will be fixed. duration, 3 hours, right? Yeah. So you can do from home in Moodle. Question appears there. Okay, in the Moodle, so you solve that. You write in a piece of paper, systematically, right? Page numbering, all those, right? And just take a photo or a scan if you have facility at your home, and then attach that file and submit in Moodle.
Okay.
Okay, so in that case, everybody will get different questions.
Yeah.
Okay, all students, there will not be same questions, right? Yeah. So because it's the system generated random generation, so that you need to do within 3 hours. Just solve problems. I'll give you some of the samples, how the exam looks like, and also we are running one quiz that is also similar to what you see in exam.
Okay.
That gives you more like experience and practice so that you can do well. Is okay? So tentatively, our exam will be week 13, Monday. Week 13, right? Yeah? It's around, I think, 10th or 11th of October, around. But I'll fix and I'll let you know.
So generally, Trom 1 starts from which
March 2nd week.
Then we're gonna have like
Three months, yeah, 3 months off, yeah.
3 months gap.
Yeah.
Oh, that's really good.
You didn't know that? Okay.
How many?
I think you can work as much as you want now. They are changing the rule from June. You know that, yeah?
Yeah.
Australian government next
Yeah.
June, they are changing back to 20 hours per week.
Yeah.
Next June 2023.
23 June, yeah.
Is it considered, sir?
So this,
Is it considered any vacation?
I'm not going with that.
no, vacation, I think you can work all. I think there is no limit during the vacation, but during the running trimester, it's 20 hours per week. Maximum.
Sir, regarding our exam, what type of exam would it be? And like how many problems would you give us?
Yeah, that's I'll give you the samples, right? Yeah, so it's around 5 problems, 5, 6 problems, right? All tutorial time.
Tutorial type problem solving.
Yeah.
So, like we have the laboratory report coming, right?
Oh, that's next, yeah.
That's next. So is it included in the quiz and the test as well? I mean, it's all.
No, just listen. First you did already, assignment 1 done.
Hmm.
Okay. Assignment 2, you will be doing this modeling and writing a report and submitting.
Yeah.
Assignment 3, there are 2 parts.
Hmm.
One is based on the lab data. Oh, I was supposed to get data today. Okay, anyway, thanks. So I'll upload the data.
Yes.
Okay, and then there are videos already I have uploaded. You can watch them, you can write a report based on those data. And the second part of assignment 3, there is a quiz.
Okay.
Some part of quiz is based on your lab experiment, yeah? And then some part is based on how you look final exam questions.
Okay.
Yeah, you attend that quiz. It's just 10%, just to make you familiar with how your exam will appear later.
Yeah.
All right, you've got it now, yeah? And then it will be the exam. It's clear?
Exam will be in November, yes, sir?
No, it's October 11, around 12.
Yeah,
Week
12.
13.
Yes.
13.
Final exam?
Yeah,
Class test.
yeah, class test. That's online. I want to do
Yeah, the
online.
class test is like final exam?
Yeah.
That's it.
Other than that, there will be no exam?
No.
Not like now.
This is to be surprised.
So I thought like class test is like.
Usually we try to remove exams, just assignments.
Okay.
Okay, so that's why that's one just the test at the end, which is I think 30% only, right, total overall. So you can do from home, but 3 hours you need to turn on Zoom. Zoom session, I'll turn on. Yeah, it's like a class test, but you do from your home. You can come here if you don't have facility. You can do from here too. Yeah, that's no problem. This room is our room. It's good. That's it. And then October, I think. What is Monday? Can you check second week of October, Monday? So we want to have that day.
September, October?
October, I think 11 or 10, 11 around.
It's 11, 10 is Monday, 11 is Tuesday. And
Okay, 10 then. Okay, we will have 10th of October. Yeah, during our time, 11 to 2. Good. Yeah, not here. At home we do it over there, but that time is fixed.
You need to practice.
It's good, yeah? Yeah. Any other questions?
No, no, sir, no.
More than
But that's a good thing is because you get, everybody gets different questions, so
Yeah.
that's all for me. So, do you know we don't have really final exam in postgraduate units? We don't. These are just a class test type thing we do in all subjects. Some subjects even they don't have that. We do, civil engineering mostly we have, yeah? So like a 30%, 40%, that's like just checking like an exam. But it's not really university organized exam. Undergraduate, yeah, university organizes like what we did in Nepal or India. Okay, similar. For undergraduate, we do masters with that. Okay, let's study a little bit. Slope stability, right? What we learned until now? Come on. Bearing capacity, and the deep foundation, palm design.
Yeah.
Retaining walls, and then what pressure theory, and the swell reinforcement last week. Okay, if you haven't gone through my recording, please go through one more time. All right, but we did the tutorials. The tutorials are very straightforward. Stepwise, there are equations put in and you get answers. Right? That's how you get exams, right? All tutorials, no theory. I'll not ask about what is swell engineering. Forget it. Eh? So just solve some problems. Yeah, some kind of bearing capacity of foundations, yeah, or the pile, bearing capacity of piles, off pressures, retaining wall, yeah, so design, those type of things, yeah. That will be similar to what tutorial exercise we did anyway. Good? Yeah. All right. So now we are doing the slope stability. I think you learned this in undergraduate, yeah?
Yes, sir.
But we'll go a little more again. In 3 topics, we have little more than undergraduate, yeah? Let's start. Is it still there? And then what? Excess stability of slopes. That's what the topics for this week, 1 week, all right? Next week we'll start some, mostly numerical this is the last week for numerical problems. After that is just theoretical, okay? So what? Describe the nature. What causes the factors? What causes the slope instability? What are the forces and the failure mechanisms? We'll learn also stability of slopes. How we analyze stability of slope? We calculate what? Factor of safety. Yeah? Factor of safety, and then if it is good enough, then it's safe. If not, that is not safe. So that's what we do. All right. Why slope exists? Natural slopes sometimes exist, right? Mountains, and hillside, and slopes doesn't. Sometimes we construct it, right? Yes, we make it like earth dams. Yeah. Okay. Some slopes are infinite, very long, right? Yeah, from the top of the mountain to very long. That's we call it, in fact, it's quite big. Some are very small, like a dams, right? We create slopes. What is slope stability? With what? Whether the swell will be there or not, right? Whether it moves or it stays in the same place. Yeah? If slope is very steep, yeah, mostly it falls, yeah? But depends on the swell. If it rock, it does not that much. But if it is clay, just goes out, yeah? Let's check some of those. Look at here. That's also right. It mostly looks like the top picture is what? Natural slope. Yeah? Bottom one, we constructed it, embankment. Look at this. What happened? Engineer. Sorry, guys. Engineer should punish for that, yeah?
No, sir.
Yeah, send to jail. No, yeah. If we do something very bad like that, yeah, we can.
No, sir, it's like common. It's like.
Then what is the difference between engineer and general public? Anybody can do that, right? But engineers, we do better.
Yeah.
Right.
It's better, sir. For, it's not like it's at all like general knowledge.
No, we should send them to jail. All right. Here you go. I'm in favor of that, right? I'm traffic road safety engineer, right? If somebody kills on the road, traffic engineers should go to jail. Yeah. Okay. Otherwise, we are losing so many lives now. Yeah. There you go. I'll talk a lot in transport. Yeah. So if there is no support, then we call it unrestrained slope. Sometimes we support using retaining walls. Yeah. So some of the component of gravity will pull. Look at this. That moves. I still don't get that idea why it moves like this in a curved surface. Yeah, you see, maybe that is the critical failure plane, right? Based on the shear strength of swell, that where the maximum reaches. Sometimes after the failure it moves, because mostly swell moves due to gravity. Let's check few. Look at this. Oh, so many good pictures, right? What happened here? Just look at this. It's like curve, right? Curved surface, like this failure, right? Slope. How about this? That also looks like curve, isn't it? Yeah. Is it forming the curve here? Yeah. Look at the failures, right? Oh, this is this mode. Big way over the highway. And then, of course, there are some other small slope failures. We call it falls if it drops. It's a flows, I mean, it's just like a mud flow, yeah, from the slope. So translational, if it just goes in a straight, not in the curve. Did you terminology here? Translational slip. And this is a circular slip. Sometimes non-circular. Some part is circular, some part is not. That part is circular, but that is translational or vertical. Yeah, that's it. And then sometimes a mix of so many. You see, a lot of failures, but only two types of failure we know a lot in analysis. We usually use this infinite slope, we call it, right? And then that's the circular. Okay, two types of failures we will be analyzing. Is okay? Yeah. Go through. Now, why slope occurs? Conditions. Number one, movement of swell along a thin layer of weak swell. If something is very weak layer of swell somewhere here, don't know, maybe in the history, something weak type of material deposited there, yeah, and it become the very thin layer. Then what happens? This top part, boom, yeah, goes away. Another can sometimes is it fails from the base. You see, very strong swell underneath, yeah, and then there is a boundary. It fails along the boundary. Sometimes it causes the failure passes through the toe of the hill, right, the slope. Sometimes what happens is that within the slope, it doesn't come even down or doesn't reach the foundation. And there's a flow slide. Of course, we learned already, right? Flow is just the mud flow over it. And sometimes all of it block moves. So many ways. So this translational slide is like not in a line, but in the curve. Okay? Rotational is in the curve. And the flow is, of course, it's a flow, mud flows over from higher ground to lower ground. Water is the killer. Yeah? For swell, water is always the killer. We need to get rid of water as much as we can. Look at here now. Why the slope failure occurs? Some causes erosion by water. Sometimes that was the original slope. Some wind or the water eroded that part. Okay, that's the one. Sometimes what happens? Scarred by rivers and streams. Sometimes look at this side of, you see, when the water flows, the river, stream, it goes, right? Current will pull out the swell and it goes with it. Yeah, there is another failure. If when there is a rainfall, and if there are cracks, do you know when cracks occur? You remember from our, the retaining lateral earth pressure? Yeah, because clay soils, they crack. Okay, so in this case, water goes in, it filled with water, and then bang. So gravity, sometimes earthquake also pushes, and then landslide occurs. Keep going. Sometimes the slope is formed by the layers of weak and strong, weak, strong, those type of things. If there is a weak layer, then slope fails. Sometimes if you put too much load on the top of the slope, then there is a movement. Why? It has, surcharge has both horizontal components, yeah? So that means the area, you remember the pressure diagram, we calculated the area. and then the slope, the pressure, the force will pull that out. Or maybe you can look at these examples, all right? So now, always, when we do the slope stability analysis, always we calculate factor of safety. So look at this, the top one is, this is the strength, okay? Along a potential failure surface, what is the strength of swell? But bottom one is how much was developed there, right? Yeah, developed along the failure surface. If you take the ratio between shear strength, then this is the factor of safety. Good? Look at this. Of course, shear strength of swell is that, right? C plus sigma 10 phi. Yeah? If this is along the developed, if you take ratio, then you get the factor of safety. Some people, they get factor of safety for cohesion itself and the factor of safety for friction angle. So we are supposed to get this both equal at the same time. I think that's all good. These are the types of analysis we need to do. Yeah? You remember I always develop a table like things, yeah? What analysis we do and how many types we have for every lecture, right? So here, first thing is we do the infinite analysis. That means slope has not the finite length. It is very long, all right? Sometimes it can be C5 swell. There is a water seepage or not water seepage. It can be Cu swell, that's a saturated clay. Why we don't have here cohesionless swell? Cohesionless swell usually it does not sustain in a long slope, right? Yeah. So, but saturated clay is very dangerous. If it like a water there, some slope occurs. Finite slope failures, right? Finite slope is a plane failure surface and then curved failure surface. Like you see like a dams or some finite width or length. In that case, there are two cases, swell mass resting on the impervious layer of swell and then Coleman method. For the finite slope, we call it mass procedure. Whole block of the failure slope is considered one block, but method of slices, right? We divide the slope into different slices. I believe you'd have done that. Okay, and then calculate the stability for each part. These are the cases, yeah? Good? So we'll cover only few of those, not all. Look at this, without seepage, what do we do? Do you know why I write this long-term factor of safety thing? Long-term means after you see this drained analysis, we talked about during our modeling also, yeah? Drained analysis, after a very long time, water goes out, right? Squeeze out. So it's a drained analysis, long-term, but short-term is what? We just apply the load immediately because water does not get chance to go out. Good, yeah? The total stress analysis we need to do. Factor of safety what? Just use the equation. Of course, they took this element as a equilibrium and then they developed equation, right? That's it. You don't need to derive this equation, just use them. All right, yeah? So critical height means wind factor of safety equal to 1. We can calculate using this relationship. For cohesionless swell, of course, it's very hard because cohesionless swell usually flows, right? Yeah, so there is no, so sometimes it must be what? Beta must be less than friction angle because what they call, there was a name, what we call angle of repose, right? Yeah, so that should be, otherwise it will not stay there. Let's do one problem then. If there is a seepage, nothing to change, just few. You need to have this submerged and saturated densities there. Use all others remains the same. I want to see one example. Oh, here you go. Can you calculate now? Come on, guys. Yeah, let's do this problem today. And in terms of, what is your paper? Pen? Yeah, come on. So what? Is there a seepage? Yeah, there is a seepage, right? Yeah, that's the condition. H is 6 meter here, and the saturated water level at the top, yeah. So sigma dash is, C dash is that, which is phi and the C, and the angle of slope is 15 degree. Calculate the factor of safety. Can you do that now for me, please? Seepage equation I need to use. Can I go back? Can you copy this now? Because with seepage here,
I'll get calculator.
so with seepage here, can you copy this formula for factor of safety first?
Yeah.
Put in your paper. Done? Substitute the values now. What is C dash in our problem? You copied, right? Formula is okay?
Yes, sir.
Okay, go back now. Can you substitute now? What is the first one? C dash is 10. Can you put those data in? Yeah. And the phi is 20, beta is 15. Saturated that. I think we do have submerged also, yeah? In the equation? Yeah, that's it. So equal to, come on, what is C dash? 10? In our problem, yeah?
Yeah.
10. Saturated is how much is that saturated?
17.8.
17.8 there, right? Can I put that here? 17.8.
26.
H is 6 meter, I think, yeah?
Yes.
That's a 6 meter there. Substitute that 6. Beta is 15 in degree, yeah? That's a 15. And that's also 15, right? Now we need to calculate submerged one from saturated, right? That's a 15. Submerged is just minus 17.6, yeah? Is that correct? So that's 9.81. You need to do that one is 17.6. Take away 9.81.
8 minus 9.
Yeah. And then, oh, that's all. Phi is, what's the friction angle? 20. That's a 20. And that's a 15. Come on, press calculator, yeah? That's in our problem.
I think that beta, sir, is 25 degrees.
What's that?
The beta, it's 25 degrees.
Is it?
Because I
Beta.
just saw
Beta is
the top one,
15.
15 degree.
but the top one says 25 degrees. It's different. Or
Come on. It shouldn't be. Oh, come on. I don't know. Why they give two different angles there? No way. What they use here? Beta, they use 15. Yeah.
okay,
No, I think 25 is wrong.
okay,
All right.
15 is
Okay. Just use 15. Yeah. I didn't see that, but I just scanned from the book. That's 15, not there. Because that should be the same angle with that.
Yeah, yeah.
The reason is it's just what we call corresponding angles, right, in geometry.
yeah.
All right, sorry. Oh, need to look at more detail here. How much you got?
0.984.
Is that correct? Yeah, what you got there?
9.985.
Yeah, good, right? Yeah, you got that. What this says you? Tell me what that number means for you. It's not safety.
It's not safe.
It's
It's less than 1.
Less than 1, critical. That slope, if there is a water seepage, yeah, through that slope, 15-degree slope, with those soil property will not stay there. Yeah, it's a failure. Okay, what's the second part of the question now? So now, you see, factor of safety, because we know already that's not safe. Okay, so use factor of safety 2 and back calculate heads now. Yeah, what's the critical height? Can we do that now?
Yeah.
Everything, put factor of safety 2 here. Yeah, everything else is same, just heads you need to calculate, not 6. Okay, so back calculate height for factor of safety 2. Yeah. Well, you need to solve here, little bit algebra there. That's it, very simple. They back calculated what, 1.62. What that mean? So you see, not 6 meter. It can sustain only what, 1.62 meter of height to
Okay.
get the factor of safety 2. Yeah, you understand? Yeah. So that's how you just try to balance the height of slope with factor of safety. Same equation anyway.
Yeah.
All good? All right. Okay, so now can you calculate the second equation now? Can you solve this by yourself? Come on. Read question carefully. Trains caught in a clay slope now, right? That means what? Phi 0. Only C value. All right, K slope and the two TV cables when the trains reached a depth of 1.9 meter, the excavation was stopped. On resumption, the top portion of the clay suddenly fell with the depth 2 meter. Is it? So that means what? It's in 2 meter when they cut the 2 meter depth, slope failed. Okay, that is collapsed. Injuring some people. Yeah, on investigating the failure, you observe the slip length approximately parallel to the original slope. That means infinite slope failure. All right, yeah. And then determine the ondent sediment. What is the C value for that soil? Good, right? So can we copy the formula first? For the clay soil, right? That's it, right? This is Cu 50 soil. Can you copy the equation first? Factor slope fail with factor safety 1, yeah? All right, can you use this formula first? Can you copy, which one? Yeah, you don't need to copy both. I think they're all equal. So first and the last is enough. Yeah. Okay, so Fs, factor safety, must be equal to 2Cu, gamma saturated head sine 2 beta. All right? Okay, let's go back to fill in the data. Okay, so let's go to there. Did you copy that formula or not? Okay. Okay. So now, can we put that one? What's the slope? Beta is 38. Can you put that beta 38? And then what was the factor of safety 1? Because it failed, right? Critical. And then can you back calculate Cu now? Gamma saturated also there. And the H is 2 meter. Can you please back calculate C?
So the critical factor of safety is 1, sir.
Yeah, of course, it's failed, yeah, because there should be 1 and then it failed. So factor of safety, you write 1 and a back calculate C. How much you got?
6.63.
Okay, 6.63. No, we got a little bit different. What happened?
16.62, sir. 17 kilometers.
Is that correct?
Yeah.
16.98.
Yeah, which is 17 anyway. Yeah. That makes sense, you see? So because since the slope failed, factor of safety is 1, then calculated C value, right? SU, they write SU, some CU here. That's the same thing. This is on-drain analysis. 16, okay? Because it's a clay swell, water is still there, right? Yeah. Easy, yeah?
Yeah.
That's the type of problem you get in exam, eh? You got it, yeah?
Yes.
It's easy, just use formula but use correctly. All right, so now second type. Swell mass resting on the inclined layer of impervious swell. You see that this is the second case, right? Another case. So what? There is a very strong swell here. Water doesn't go in, impervious layer, right? So top portion it fell. So we need to calculate the factor of safety again. There is a factor of safety equation. Good? Yeah? So just you calculate factor of safety for this. Instead of looking at this diagram, derivation of formula, forget that. Just let's do example to use this equation. Come on. Oh, look at my scan. My scan was not good. Hey, can you read it?
Yes.
Yes. All right. The size of a triangular, this is the one right here. And then this scale from drawing L35. Can you use just the meter one, not the feet unit? Okay.
Yeah.
10.7 is what? L is 10 points. So from here to that point, the length of this is 10.7. And then theta, this angle of the tailor plane is how much? 20 degree? 24. The height of the triangle normal to the L is 2.13. That means 2.13. Just to calculate area of this triangle. All right, okay. Data you have is. And then the C value is 2.4. And the phi is 20. You need to add that. What is the factor of safety against sliding? Okay.
Yeah.
So we got the data. Let's go back to our equation first. Can you copy that equation first? W equal to C dash L plus W cos alpha 10 phi W sine alpha. Alpha is here, slope of the failure, what the impervious layer, right? Can you see in the picture? Alpha means?
Yes.
That's it. W is weight of the swell. That block, triangular block. You copy it?
Yeah.
All right, let's go. Can you calculate weight of that now? Let's do it slowly. So half, what is the area of triangle? Half base. Base is half. I'm calculating W, all right? So half and times base is L. L is what? How much is it? 10 point?
10.7.
10.7. Half base times height is H. H is 2.13. 13, that's the area we got. Unit width and multiply by density of swell. How much is that?
10.7.
Unit weight, I mean. This, I don't know why it comes, and then okay, times, what is the unit weight of swell? 15.7?
Yes, sir.
Yeah, can you calculate the total weight now?
178.9.
How much?
178.9.
178.9 kilonewton, right? Yeah. 9 kilonewton, that's W. So now calculate factor of safety. Can anybody give me equation now? Factor of safety equal to C dash L. Yeah, C dash L. C dash is how much is that? 2.4. 2.4 times length is total, which is 10.7 plus.
W
So W is 178.9. We just calculated.
cos alpha.
0.9 cosine, yeah?
Yeah.
So cos alpha is the angle of that one is theta here, right? Cos, cos 24, yeah?
Yeah.
24, that's it?
Tan pi.
The tan phi is still there, right? Tan phi is the swell. Swell phi is 20 degree. Okay, divide by
W
W is the same thing, right? 178.9, one.
sin alpha.
Okay, sine 8.9. Sine alpha is 24. Sine 24. Can you do this calculation? How much you got?
1.17, sir.
1.17?
Yeah.
Okay, let's check answer there. Yeah, 1.2, right? 1.17. They did both, right? The feet as well as the other units. So that's good. Why I need to do this is because I need to take from different books because I have different cases, right? I only have the example of each case to show you the calculations, right? Yeah. That's good. Is it safe? I know it is more than one, but 2 + 2 1. Don't want to go to jail.
Yeah.
Okay. So maybe recommend not safe. Yeah, so for something, be on safe side all the time. All right, let's keep on going. So now that's the second method now. C5 swell. There's a Coleman method. In that case, failure always passes through the toe. Here, all the time, right? Did you see that? That's the polar line with exit angle of theta. And then that's the beta angle is the slope angle. Yeah, you gotta get this all data correctly, right? And then we need to use this formula. Okay? So now CD developed that, and then its critical height is that. So usually this is the relationship we need to satisfy. Ratio of the shear strength to developed shear strength is ratio of phi angle to developed phi angle. That must be same. Okay? So that's the condition we need to satisfy. Let's do one example. Okay, let's do that. Can you sketch that graph first? Yeah, based on the information, can we do that first? Yeah. All 1.8 meter deep vertical wall fence is to be dug in the swell without soaring, so no support provided. The swell unit weight, angle of internal friction, and equation are 19, 28, and that unit square require factor of safety for this fence using the Coleman method. All right, yeah? So go for this. How much is the height? Can you sketch? Did you sketch that, right? How high is that? Come on. Angle of slope. There is nothing given, yeah? So it's just the general factor of safety then. So can I draw here? 1.5 meter deep, right? Height is 1.5, 1.8. Sorry, yeah? That's it, 1.8. Swell unit weight, that's that one. So the factor of safety using that, that's a trench. You see, like that, 1.8 meter there. Yeah, factor of safety. So now height is that. So what's the equation for height? Can you copy this first? C dash. Which one is better? This one is better, yeah? So can you copy this equation first, yeah? CD there, and the C is given, yeah? And then assume phi, and then you do calculate CD, they must be same. 10 phi dash CD. Yeah, okay. So everything is known there, right? Phi developed. What do we need there? So that's the one, SCR. So trial and error we need to do because we need to balance out. CD is that. Yeah, that's okay. That's the correct equations we are using, right? Yeah. Okay, so the critical height is 1.8, right? You can use also that. I think they are the same. So what we know already, beta we know. Yeah. Phi we know. Oh, everything is we know. So I think the C dash we know. So it's better to use these to calculate C developed. CD by gamma dash. Can I have a little bit look on that? For CD, that's the developed. I think I didn't correctly put the equations in order. So that's a one CD. So that's the critical height. Same phi dash.
Same.
That is the factor of safety 1, right? CD, so C developed L1 because of the critical height is 1, yeah? How much? 1.8. All right. So now, ID 4 sigma. Okay. Did you copy this equation? Can you put in your? Because if its critical height is none, 1.8, so I think we can find the developed one. But CD is depends on there. So how you get that both at the same time? Sine beta cos delta, right? Yeah, that's it. That's 1 cos beta minus phi. The critical height is that. Beta equals, so you need to use that for 10 phi, so for 10 delta. Okay, I'll have a look on this a little bit more. So how we do is, that's the one. So B phi beta, we need to use this. Okay, makes sense, right? Factor of safety 1 means that must be equal to that. So can we just use, what is C dash? Can you put that in? Come on. So if factor of safety is 1, okay, yeah, that's the trial and error, that's good. So if factor of safety is 1, so CD must be C dash, yeah?
Yeah.
So can you calculate that now? How much will be phi? Phi D now, based on that, because that's the same, right? Ratio is same. Maybe the best idea is, you see, first you assume factor of safety 1. You good? Got it? So you calculate 10 phi D. Okay, so that means 10 phi divided by factor of safety phi, which is first I assume 1, right? Yeah. Because we can't, because there are two unknowns in one equation. We can't just directly calculate that here. So we need to do a few things. So can you check now? So 10, 28. So if I use phi D equal to 28 now, because that's the same, yeah? So now beta is 90. Why beta is 90? Vertical trends, yeah? Yeah? Slope angle from the horizontal to the slope is 90 degrees, isn't it? Yeah? That's a beta is 90. Then you calculate critical height here. All right, yeah? So you calculate critical height is 1.8. Calculate back CD from the second equation. Yeah? And then you calculate factor of safety for C, that's a 3. But what we assume here? 1, they are not same. So keep trialing now, right? It is not equal to 1. Have another trial, yeah? And then keep doing, and then plot the curve, and there will be one thing that's critical. Okay, so let's do first, right? Yeah? Can you copy 2 equations first? Can you do this equation in your paper? Side of the paper, first one. And then you also copy this equation in the side by side, okay? Can you do that? So now start assuming factor of safety 1 first. Okay, that is not final answer, all right? If we assume 1 from this, can you calculate what is CD? Yeah. Equal to C dash, right? How much is C dash given in the problem? Did you copy data or not yet?
No, no.
Okay, can you just type those data first here? Okay, can you do that now? C dash is, equation is 20.2. Yeah. Okay, phi is 28. And the gamma is 19. Yeah? And then 1.8 meter depth. Is okay?
Yeah.
Copied, right? Okay. So copy these two equations now. C over C dash, right? And then that equation also. All right. So now, when we assume factor of safety 1, so CD would be what? Whatever is C.
Yeah.
So then what happens? Phi D would be 28. But how much is this divided by factor of safety 1 now, right? When you get that, and put in this equation now. SCR is 1.8. Can you write that? Yeah? Just put these values in, and then what is you need to find is ID, that value, developed value of this. Can you calculate that? Yeah? So there will be 210, right? Yeah, which one is quicker? To calculate 5D, that is quicker or that is? SCR, I think that should be all right. Everything is none here, only we need to calculate 5D. That also doesn't look straight calculation, right? Yeah? There you go. So you put that in the equation, that's a SCR. Yeah? Okay, 5D, whatever we assume, then calculate back to CD. If we get the CD, same as what we assume at the beginning, well, how much was CD, C value, first trial?
C value
20 points? I think this is not good to explain there, eh? Let's go here. Do we have somebody has one extra pen?
Yeah.
Let's start doing from here. Can I borrow now?
Yes, sir.
Thank you. Let's do that problem. Right? Yeah. So now we draw this 1.8 meter. Yeah. C equal, how much is that C value there? 20 points?
20.2, sir.
20.2. Phi is?
Phi 28.
So 28, right? Yeah. And then there is a 1, gamma.
19.
19, right? I think hopefully you need all good, yeah? Now, first trial. Trial 1. Okay, remember C dash divided by CD equal to what? 10?
10 phi dash.
Phi dash divided by 10?
Phi d.
Phi d, right? Developed one and then original swell strength. All right. So now, can I C dash over CD equal to first factor of safety 1, right? We assume 1 because that's the factor of safety here. All right. So in this case, can you calculate phi d now? What happens? 10 phi d equal to, that's a 1, yeah?
Yeah.
So then it's 10 phi. Yeah, which is what, 28?
Yes, sir.
10, 28. So phi is 20, phi d is 28, isn't it, right? So phi d is 28 here.
Yeah.
So now let's use the second equations of the SCR. Can I go back to that one? Can I copy that equations? Next one, that one. Can I copy the last equation here? SCR equal to 4 C dash over gamma. So sine beta cos phi. That's a D now, right? I need to get from there. Phi D divided by 1 minus cos beta minus phi. All right, yeah? Okay, so now, so I copy this. Can I go to this one? So can you calculate now? SCR is what? 1.8 equal to 4. What is C dash we assume until now is 20.2. 20.2 divided by 19. And then this is CD. So, okay, leave this CD. Okay, so don't put that one. We are calculating back to CD to get that value. All right. So now, so sine beta is sine 90. Cos 28, because we get D28 just before. And then 1 minus cos 90 minus 28. Can you do this? Whatever you get CD. Just solve for CD, right? Sine 90 cos 28. 1 minus cos 90 minus 28, yeah. Can you calculate CD now? Just substitute that as a C dash is CD because I'm doing that as develop. That's also developed. Right? You got to write that CD. That's it. How much you got? CD. If I get 20.2, I don't need to do any further. I got the same thing, but we keep doing until we get that done. How much you got?
5.13.
5 point? Can we just check, yeah, if they calculated the same thing?
Yeah, 5.13.
First calculation is 5.14 there, yeah?
Yes.
Makes sense, yeah? Good, all right. So now, but what happened now? Factor of safety, how much we got that? Factor of safety equal to C is 20.2 divided by CD is how much? How much you just calculated? 5.13, yeah?
Yeah.
13. How much is factor of safety now? So 3 point something, even 4. 3.93 factor of safety. Now, that didn't match to 1, right? Let's keep going the next. So trial 2. Let's use factor of safety this. Yeah, whatever we got. Okay. So now, if I use factor of safety 3 point that, so can I calculate that now? C dash divided by CD equal to what? 3.93. Yeah? What happens now? So it's 10 pi.
So can you show your solutions?
Oh, sorry, yeah. Look at here. Okay. So 10 pi over 10 phi d must be same, right?
Yeah.
3.93. So now can we calculate 10 phi is 1028? Good. Divided by 3.393 must be equal to 10 phi d, yeah? Good. How much is phi d now? 1028 divided by 3.93 and you do 10 inverse. Okay? So 1028 divided by 3.93 and then calculate inverse of that is, well, how much is that? It should be in degrees. 1028 divided by 3.93?
0.13.
0.13, but you need to do 10 inverse
Yes.
to get phi d, yeah? How much is that?
7.705?
How much?
7.705?
7 degrees, that low? Maybe because it's a 3, right? Almost 4 factor of safety. I can check there. Oh, come on. I can check that, right? So what we got when we used the second time? Oh, they used the different factor of safety. Didn't use exactly that, 3 point something, yeah? They used 2, they used 3, and then plotted the graph.
Yeah.
Okay, so I think it should be all right. When they use 3, how much they got phi d?
10.0 something.
10, oh, it makes sense, right? Because
Yeah.
3 point something is 7 point something, that's all right, okay? It's good. So now can you calculate back CD again from the same equation? 1.8, 4 times CD divided by 19, sine 90, cos, how much we got? 7.7,
7.7.
all right, okay, 7.7 divided by 1 minus cos 90 minus 7.7. Can you calculate CD now from this? Because we didn't do that, follow that, but yeah, this is good. I just want to check this. How much we got CD now?
Sir, can you show your solution?
Yeah,
Thank you.
a CD. Now I want to get CD for the trial 2, 3.93. All right, yeah. How much is this CD? Come on. No calculator?
Yes, sir.
How much you got?
0.47.
How much?
7.47.
7.47, right? Look at here. So now can we check here? So if CD is 7.47, so times 3, did we get the C value 20.2 or not? Can you multiply that?
Yes, sir.
With that? Of course, it's more than that. It's not making sense, right? So that means factor of safety 3.93 is not possible. We need to lower a little bit. Let's trial 3, factor of safety 3. Can we use that now? Yeah? So 10 phi, let's do this all because we have solution, right? 10 phi divided by 10 phi d equal to what? 3. Good?
Yeah.
So what happens now? 10 phi d equal to 1028 divided by 3. Okay, so that means phi d equal to, come on, can you give me the angle? What happens from there? 1028 divided by 3, do 10 inverse of that.
10.05, sir.
10.05 degree?
Yeah.
Good, right? We got phi d. So now put in the same equation again there. So what happens? 1.8 equal to 4 times CD divided by 19 sine 90 cos 10.05 divided by 1 minus cos 90 minus 10.05. What do you get CD now? Oh, look at this. It went out, yeah? CD, can you calculate CD out of that?
Yes, sir. Just a minute.
Yeah, just that multiply to that and
7.70.
is it 7.7?
7.17.
7.17. How did you get that? Yeah. Okay, so that's a 17 kilonewton per meter square. Now, if you multiply that to this, you should get 20.2. Is that correct? C dash equal to 7.17 times 3.
21.5.
You see, closer, isn't it, right? It's coming to that position. So factor of safety should be around 3. Do you understand? Is this how we did?
Yes.
Yeah? Just because both should be same. So first, assume some factor of safety, calculate phi d using the equation, calculate CD, and then check whether the ratio of CB also is the factor of safety or not. We need to do few trials, that's it. Because 2 unknown, 1 equation. We can't find both of them unless we do trial and error. All right. So that's what they have done here. You see, look at here. So they use first 1, and then second time is 2, second time is 3. Yeah, that's what 7.17 that we got. Yeah, and then ratio is factor of safety 2.82. We use 3, right? Not exactly matching, right? But we already know. Yeah, what they did is very clever, right? Just plot 3 points and then draw the line where it crosses, right? But one more time trial, we'll get that.
Yes.
Okay, so it should be a little bit lower than 3. Okay, I think done. So what is left now? Oh, that's a curved surface. So we will continue this on Wednesday. Is okay? Okay, thank you guys. Yeah, please try these tutorial problems. Hey, all right.
Sure.
I think, can you wait for some time? I think I should have uploaded some sample exam questions. If not, then I'll check and do that. Can I check now? I believe so. Oh, this always asks, right? Yeah. All right, that's the Moodle unit. All right, so now I think week 12 revision. Review, yeah? Oh, lecture review, not yet, okay. So can I, well, I thought I have that, but so nothing here. Okay, I'll upload one sample exam questions in week 12. Okay, over here, there will be one file that gives you the type of exams questions you get. All right? Okay, thank you. See ya.
See you, sir.
Thank you.
Thank you, sir.
What time are we going to?
Tomorrow or today?
What do you prefer?
It's your pen.
Let's go, guys.
Which time do you start your job? Which time do you start your job?
Meeting started.
3:30.
Morning?
Meeting started. Any తెచ్చుకుని అక్కడ 2:30 అయిపోయింది టైం
You got the number?
Yeah.
Just make a group, WhatsApp group. You got a WhatsApp group?
I have a
ట్రైన్ ఎక్కడికి వెళ్దాం మార్కెట్
Just give me.
తొందరగా వెళ్ళి తెచ్చుకోవాలి.
Yeah.
బ్యాగ్ ఇక్కడ పెట్టాము ఫోన్ ఉందా
కావాలి
2165. JVL, yeah? JVL, yeah?
E.
EM?
EM. Yeah.
Okay.
So you are Sandeep. Is our group big, right? Yeah. He said that we're not really going to meet. We're just because we just want to take a screenshot.
Hey, I just have questions regarding this assignment, like Australian engineering practice, the second one. I'm not really like getting that, what to do exactly.
Part A or
Part B is okay, part A.
part A, like, you have to like, just compare the three, yeah? That's it.
Compare, just
Yeah.
comparing
Just make the comparison.
between the three.
Yeah, between the three, not the first assignment one, but between the three.
Okay, so regarding selecting the topic, so
Yeah.
we need to consider the whole thing because for separate keywords, we get lot of topics, right? Like maybe concrete or maybe 3D printing and all. I have selected that topic, so I'm getting lot of topics.
Yeah.
So what it's my wish or what?
Yeah, it's your choice, whichever you can like, just relate it, but you can take three topics.
Related,
Related to assignment one.
related. Concrete, I have lot of articles, but 3D printing, yeah, they're less. I'm a bit confused about it. So influence of phase change, maybe there's a big headline.
Yeah, there are lots.
So I need to sort out that one.
I'm confused about part B.
Yeah, you're just going to get successful and unsuccessful project.
Yeah.
And then you're just going to discuss it.
Yeah, discuss it.
How-
Discuss how.
Successful and unsuccessful project or case study, brother. I
Yeah,
can't find the case studies any in the article like Google Scholar and
And
she
you
will
could
like.
try, is it, maybe.
I think I'm missing like some keywords to find the case studies because the failure and successful project are always case studies. Not a research paper.
Yeah.
Yeah, it's a case study, always a case study. Yeah.
Case study.
Yeah.
And not an article.
It's not an article, man. It's a case study. Yeah, it's an article, but not a research paper.
And not a research paper.
Yeah.
Okay.
But I think we can
How
cite
about-
it.
How about like what we did?
The
Selected
article,
projects in our presentation.
Yeah.
Is it a successful project?
That's a research paper, man.
And a solution paper.
That's a research paper. And case studies like studying the only the building.
Yeah.
Why did you fail? That's a case study.
so the 3 topics should be a case study.
I have no idea about that. I have also just left the B part B. I haven't written anything about
Part B, like, you don't have to be related to
Yeah,
part A. That's
Yeah.
what it is.
It's not-
different. Yeah.
If you can write by any of the topics like concrete, any concrete structure failure. If you get any about like case study about that, and you can just like you can update it just.
Whatever we do, man, that man doesn't give
I
much.
create a group. Okay. I created a group. Okay. I'll just add the Savita.
Okay, sure.
And let's discuss today. And if you like, I got a job after 6 o'clock. We can. Yeah. After 6 o'clock, we can just if we can participate in 4:30. That's okay.
Or 30 after this.
సరే ఏం తెచ్చుకుందాము ఎక్కడికి
Then
వెళ్దాం
we
చెప్తారా?
will create like
Tomorrow is good, yeah.
we will go to easy. You can
Your assignment already at work.
find.
ఏముంది
No, why
సబ్వే
do
వెళ్దామా
we like
సబ్వే
it will take us 5 to 10 minutes, man. Not
నీకు
like
డెసర్ట్ కావాలి కదా
ఏం తీసుకోవచ్చు
నీకు డెసర్ట్ కావాలి కదా
నాకు డెజర్ట్ కావాలి
నాకు తెలుసు కదా సర్లే సబ్వేలో
సబ్వేలో డెజర్ట్ ఉంటుందా సారీ సబ్వేలో డెజర్ట్ ఉన్నప్పుడు నేను
మెగ్డీలో ఒక డెసర్ట్ తీసుకొని సబ్వేలో ఓకేనా
ఓకే నో ప్రాబ్లం సబ్వే ఏంటి ఎక్కడ ఉంది అది నేను చూడలేదు
బ్యాక్ సైడ్ అది సాగు బయట
పిచ్ అసైన్మెంట్ లేదు నాకు 100 అసైన్మెంట్స్ ఒక్కటి అర్థం కాదు వాడేమో
అర్థమైంది పక్కన పెట్టు అది చేయాలంటే చిరాకు వస్తుంది
వాడు పెట్టే ఈమెయిల్ చూస్తే నాకు చిరాకు వస్తుంది అప్పుడు
అసలు వాడు మాట్లాడింటే అర్థం ఒకసారి నిద్ర స్వామి కావాలా కానీ ఈరోజు పొద్దున్న నుంచి ఏదో బాధగా ఉంది మా